Okay, let's start with cooling and dehumidifying. I have here two problems nitong topic na to. So we have been tackling about yung kanina, yung heating and humidifying, ngayon cooling and dehumidifying. So in this process, okay, to refresh your memories about the discussions na nagkaroon tayo nakaraan. Saan ba yung salamin ko? Sa simultaneous cooling and humidification of the air will take place anytime the air is passed across a cooling surface or through sprays of cold water. So, para palamigin natin yung hot air, ni-sprayan natin siya ng cold water. Kaya nga tayo mayroong mga chilled water system eh. The air is chilled. Ayan o, di ba? May mga chiller system. Sa mga malls, yung mga units nila ng air conditioning doon, centralized, ibig sabihin, there are chiller systems na ginagamit nila at yon yung piping ng chiller systems na yon which supplies cold water for service doon sa ating entire establishment, doon kumukuha ng cooling supply yung mga stalls na meron sa malls. Ganun yon. So, it is chilled below its dew point temperature, thus condensing out moisture. So, namawala yung moisture. The leaving air is lower in dry bulb, wet bulb, and moisture content than the air entering the spray chamber. Now, what happens in the SH? The SH is generally higher at the start compared to the outlet. And then, when cooling coils are used, the temperature of the film air in contact with the surface of the metal pipings, yung sinasabi ko, the chilled water system supply, determines the condition of the air flowing through the coil. The temperature of the surface film is always at some point between the temperature of the air and the temperature of the water. So, para nagkakaroon sila ng thermal equilibrium between the two. Or often, the refrigerant inside of the coil. So, refrigeration system. Okay? May involve yung refrigeration system. Now, we analyze the system. Okay? Dito muna sa ibaba nito. For system analysis, if this is the problem, basahin ko muna. 12 kilograms per second of outside air at 40 degrees dry bulb and 25 degrees wet bulb undergo cooling process using cooling coils to a temperature of 10 degrees Celsius dry bulb at saturated condition. Okay? Bakit sinabing saturated condition? Number one, kapag sinabing saturated condition, your RH will be at 100%. Pareho yung wet bulb, pareho yung dew point dun sa iyong dry bulb. Determine, number one, the mass of water vapor extracted in the air in kilograms vapor per second. B, QT, the total heat, the latent heat, and the sensible heat in kilojoules removed from the air. Letter C, the air is reheated to 17 degrees Celsius after the process of cooling. So, meron kang inilagay na reheater. To compute, now, you have to compute the sensible heat added in kilowatts and the capacity of the reheater. Medyo mahabang problem to. Now, letter D, the volume of the air at the entrance after the cooling process and after reheating in cubic meters per minute. And E, what is the capacity of the cooling system in kilowatts and in tons? The capacity of the cooling system, ibig sabihin the refrigeration capacity na in-apply mo. Okay? Now, we first analyze the problem. We have to draw the diagram. Mas maganda din na drawing natin eh. Sa lahat ng subjects ko, what better way to understand it is to draw the diagram. So let me draw the diagram for you. Pagpasensyahan nyo na medyo groggy yung kamay ko dahil ako'y medyo nilalagnat. Pero wala akong COVID. Pagod lang. Fatigue. So, meron tayong simple refrigeration system. Simple vapor compression system. This is the compressor. Will go to your condenser. Yan, condenser. Expansion valve after nun. Throttling process ang mangyayari. And then evaporator. Ano daw yung capacity nito? Now, sa refrigeration, ano bang ginagawa niya? Nagi-give off ba siya ng heat? No. Actually, sa refrigeration system, it takes off the heat from the body it came in contact with, like the air. Okay? Nag-a-absorb yung refrigeration system mo nun. So, if this is your air, it is composed mainly, pag tinanong kayo, air is composed of what? Sir, nitrogen and ano? Sira ulo, pang combustion yun. Dito sa air conditioning, simply your air is composed of dry air and water vapor. Wala na nitrogen and oxygen. Doon ka sa combustion pumasok kung gusto mo matuto nun. Okay, this is point 1. Okay, you have different conditions at point 1. Meron kang dry bulb temperature at 1. Meron kang wet bulb temperature at 1. Meron kang mass ng air. And syempre, yung air na to is simply meron kang dry air and then mass ng water vapor. And then lalabas yan sa 2. Meron kang mass ng dry air 2. Meron kang mass ng water vapor 2. Tapos meron kang temperature dry bulb 2. Tapos meron kang temperature ni wet bulb 2. And yung heat na meron dun sa air mo, it will be given off dun sa ating system. Okay? Ng refrigeration. Ayan o, ref system. And then, after mag-pass dun sa cooling coils ng iyong evaporator, condensate will be given off. Yan yung analysis. Now, using material balance, okay? Lagi tayong magaganito para hindi kayo nalilito. By material balance, ang titignan lang natin dyan yung quantity ng air and then the masses that came in and came out. So, you have here air. Papasok ka dyan at point 1. Meron kang mass ni dry air, 1. Tapos, meron kang mass ni water vapor at 1. And then, yung condensate mo that is given off to the system, mass ni condensate. And then, lalabas yan as mass ni dry air, 2. Tapos, mass ni water vapor, 2. Now, let us see. Okay? Yung dry air mo, dry air analysis, mass ni dry air, paulit-ulit na lang yan, is equal to mass ni dry air 2 is equal to mass ni air total. O, lagi na lang yan, ha? Yung water vapor naman, content, water vapor, condensate, water vapor 2. So, mass ni water vapor 1 plus mass ni water vapor 2 equal to, water vapor 2. Sorry. Mass ni condensate equal to mass ni water vapor 2. This is true. Okay? Yung pangalawa. Pwede pa nating i-simplify yan. So, the mass ni condensate is equal to mass ni water vapor 2 minus mass ni water vapor 1. But, di ba, yung mass ni water vapor, as you can see, di ba? Ito, di ba? Yung mass ni air is equal to, sorry. Mass ni water vapor, hindi pala air. Yeah, di ba? Yung SH natin is mass ni water vapor divided by mass ni dry air. Pwede nating makuha si water vapor. As you can see, mass ni water vapor is equal to SH times mass ni dry air. Pwede mong mailabas dito si water vapor, yung mass ni water vapor. Okay. So, here, yung mass ni condensate is simply equal to mass ni air times SH2 minus SH1. We have arrived with this. Okay? Ayan yung analysis natin. Now, by using energy balance, yan, by energy balance, where the energies are at equilibrium, okay? Meron ka ulit air, pumasok dito, then Q is given off, okay? At 1, meron ka ditong mass ni air, and then H1, mass ni air 2, and then H2. So, itinapon pa rin dito yung mass ni condensate, and then yun, merong yang enthalpy ni condensate, okay? Water. So, by energy balancing, E in is equal to E out. Okay. So, pagsamahin natin lahat ng in and out, tatlo yung out, isa yung in. So, mass ni air, H1 equal to Q plus mass ni condensate, H ni condensate plus M ni air, H2. Pagsamahin natin yung mayroong enthalpies. Okay? So, Q plus M condensate, H ni condensate equal to M ni air, factor out yung mga H, factor out si air dun sa H's, H1 minus H2. Yan. So, ano yung meron tayo dito? Itong Q na to is the sensible heat, QS. Ito is QL. And then this one will always be QT. Now, himayin natin. Yung QS natin dyan, sensible heat is mass ni air, CP ni air, tapos yung watt. Ano yan? dB nung hot minus dB nung cold. That is QS. How about QL? Sir, yung QL dyan is mass ni steam. No. That is not mass ni steam kasi refrigeration system na yan. QL is simply mass nung air that came in contact with that and tama ba? Delta SH and multiplied to 2502 kilojoule per kilogram. Kung sa steam kanina, mass ni air or mass ni steam, tapos delta SH. Kaya lang, di ba itong mass ni air, tandaan nyo, yung mass ni air dyan is simply dun sa condensate times delta SH. O, extract natin. Mass ni air, SH nung high, minus SH2, tapos 2502 kilojoule per kilogram. That is for QL. And QT is still the same. Ay, ito pa rin ang QT mo. Okay? Where QT is equal to QA. Ano ba yung QA? Sir, that is the heat absorbed by the refrigeration system. Ayan, hindi na siya yung total heat. That is the total heat absorbed by the refrigeration system. Okay? So, let us go with the example. Okay? Recall natin. Meron ka dyang 0.1, 0.2. So, 0.1 mo, okay, is 40 tapos 25 degrees Celsius wet bulb. It underwent cooling process. Ayan ang mga pinahanap natin. Okay, saturated na siya. So, let us go with the solution. At 0.1. Okay, punta tayo dun sa app natin. So, dito, Okay? Ang lalagay natin. Dry bulb and wet bulb. 40 ang dry bulb. Ang wet bulb is 25. So, we have to find in dew point. Lista ko na ha. Temperature dew point 1, RH 1, omega 1, V1, and then H1. Ano pa ang kulang? Wala na. Ay, nandyan na. So, hanapin na natin sila. So, dew point, 18.997. Yan. 18.997 degrees Celsius. RH will be? RH. Nasa RH? 29.758. Correct. 29.758%. Relative humidity. Okay na yun. Humidity ratio, 0.013. 0.013842. 0.013842 kilogram vapor per kilogram air. Specific volume, nasa baba. 0.907 meter cube per kilogram. And then H1 will be 75.851. Okay. 75.851 degrees tuloy. Kilojoule per kilogram. Kilojoule per kilogram. Now, we will go at point 2. At point 2, hanapin natin si dew point. Saturated yan. RH is 100%. So, tandaan nyo, temperature dry bulb 2 is 10 degrees Celsius. Ngayon, pag sinabing saturated, RH mo is 100%. Hanapin natin yung dew point. Yung wet bulb. This is 2, this is 2. W1. 2 pala. W2. Specific volume 2. And then H2. Okay. Type in natin. This is 10 and 100. Relative humidity. 10, 100. Dapat ano siya, bumaba. Pabalik. Pabalik yung graph. Okay? Tingnan natin siya. Okay. Submit. Bumalik dapat yan. Ayun, bumalik na siya. Naging saturation line. Nasa saturation line siya. Okay, pare-pareho. Yung dry bulb, wet bulb, tsaka dew point. Diba? Sabi ko kanina, pare-pareha sila. This is 10. This is 10. Kasi nga, relative humidity or saturated siya. Okay. Humidity ratio, 0.007661. 0.007661 kilogram vapor per kilogram air. Specific volume is 0.812. Meter cube per kilogram. Enthalpy, mas mababa yan. Excuse me. 29.357. 29.357 kilojoules per kilogram. Okay, nahanap na natin all of the given. Yan. So, by material balance. Now, for material balance, na ano na pala natin? Nakuha na natin yan. Yan na. So, mass of the condensate, hanapin natin. Mass of condensate. is equal to M air SH. Mas mataas yung SH ni 1 kaysa 2 minus SH2. That is 12 kilograms per second. Tapos SH1. Ano yung SH1 mo dyan? Ayun, 0.013. 0.013842 minus ito. Check natin. This one and this one. 0.007661 kilogram vapor per kilogram. Cancel to, cancel. Ang lumabas is kilogram per second. So, 12 times 0.013842 minus 0.007661. Yan. So, mass of the condensate, 0.074172 kilograms per second ng condensate. That is letter A. Check natin kung tama sa A pinahanap. Okay. QT, QL, and QS in kilojoules. Hanapin natin si QL. QL. M ni condensate multiplied to 2502. Pwede na yun, kilojoule per kilogram. Nahanap mo naman na eh. Okay? Ito na yun eh. 'Di ba equal din naman yun sa M nung air tapos SH1 minus SH2 multiplied to 2502 kilojoule per kilogram. Pero nahanap mo na nga, okay? Pag nahanap mo na, wag mo na hanapin ulit. 0.074172 kilogram in every second nung condensate tapos 2502 kilojoule per kilogram. We cancel all the same units. Kilowatts. Hindi kilojoule yan. Kilowatts dapat. O, di-multiply natin ng 2502. The answer is 185. Ang laki pala nung air conditioner mo. 185.5783 kilowatts. Ibig sabihin, meron kang centralized unit. Ang laki ng power consumption yan. Kasi ang laki ng load eh. Now, yung QS. Yung MA, CP ng air, dry bulb nung hot minus dry bulb nung cold. Now, yung M nung air, what is the M of air? Mass of air. Nakuha ba natin yung mass of air dyan? Binigay yan eh. Ayun, 12 kilograms per second. 12 kg per second multiplied to 1.0062 kilojoule per kilogram degree Kelvin multiplied to dB. Dry bulb niya is from mababa yung una pataas. Ayun, pinalamig. 40 tapos 10. 40 minus 10 degree Kelvin na to. Cancel all the same units. Ito. Ito ang lumabas kilojoule per second. That is in kilowatts. 12 times 1.0062 times 30. Mababa yan. 362. Yan. 362. 362.232 kilowatts. That is for QS. How about QT? QT, pwede naman to. QL plus QS. O, di add mo na lang. 362.232 plus 185. 185.5783 kilowatts. The answer for QT is plus 185.5783. 547, ang laki nga ng ano mo, ng cooling load mo. 547.8103 kilowatts. That is QT. Now, this is also equal to QA, capacity of the refrigeration system. This will become the capacity of the ref system. Eh, anong hinahanap natin? Okay? Di ba ang hinahanap natin is in tons of refrigeration. So, this is in kilowatts. Paano natin ita-translate yan? QT is equal to QA. Oh, 547.8103. Ilang tons of refrigeration per kilowatt? Okay? Hanapin nyo. Ilang tor? Hindi na natandaan. Oh, 1 tor is equal to 3.5167 kilowatts. Oh, hindi na natandaan ha? Tandaan nyo yan. So, divide natin ng 3.5167. Pag hiningi sa inyo. So, that is 155 or approximately 156.77 ano na lang to? 774. Tor. Approximately 156 tor. That is the cooling capacity of the refrigeration system. Okay? Pwede rin nating solve. Check natin. Yung QA is equal to QT. Equal to mass ng air multiplied to H1 minus H2. Check natin kung tama. Yung mass ng air is 12 kg per second. H1. Hanapin nyo. H1 is 75.851. 75.851 minus yung H2, 29.357. 29.357 kilojoule per kilogram. Cancel all the kilogram, kilowatts ang lalabas. So, 12 times 75.851 minus 29.357. The answer is 557. Almost the same. 0.928 kilowatts. Pwede na yan. Anong hinahanap dyan? Nahanap na natin si QL, QS, QT. Now, if the air is reheated to 17 degrees Celsius, bagong system na naman to. Ito pa lang ang na-solve natin. Okay? Ito pa lang part na to. How about this part? Yung E. Okay? C to E. Now, for letter C, habang problem to. For letter C, bagong system yan. Naglagay ka ng reheater ng heating coil. Now, lumabas siya dito sa point 2 mo. Ayusin ko yung drawing ha. Lumabas siya sa point 2. Okay? This is point 2, okay? Naglagay ka naman ng heating coil, reheater coil. Yan. Tapos lalabas siya dito sa 3. Meron kang dry bulb, papasok dito. Ito yung air mo. Imbis na magbigay ka ng init, ito namang heating coil ang nagbigay ng init sa'yo. Nagdagdag ka ng init dun sa hangin. So, lumabas dito is dry bulb to 10 degrees Celsius. Tapos ito RH, saturated 100%. Ngayon, what happened do sa 3? Tumaas naman ng dry bulb ulit kasi nag-heating coils ka eh. 17 degrees Celsius. And then, ang sabi dito, kapag nag-heating ka, yung specific humidity mo is the same lang. Yun lang naman yung process nun eh. In W2 and W3 or omega 2 and omega 3 are same. Okay. Dodrawing ko mamaya yung diagram niyan, ha? So, saturated ang air mo, in order for you to find yung heating coil, that is equal to mass ni air, H2 minus H3 pala kasi mas mainit eh. H3 minus H2. Now, sir, anong gagawin ko dito? Okay, 17 tsaka ano? Plot mo ulit sa iyong psychrometric. So, 17. Ano yung specific humidity nung pangalawa? Nahanap mo dyan. Dito sa 2. Ayan, 0.007, bali 7.661. 7.661. Hanapin mo na kagad. Hanapin mo na to, yung mga values niya. Ito yun, QRH. Tapos, yung Q nung heating, yung total Q kasama na yung heating. Mass ng air, CP ng air, yung dry bulb at 2. Hindi, dry bulb at 3 minus dry bulb at 2. Ito na yung dalawang formula na kailangan mo. Hanapin natin at point 3. Excuse me. RH3, temperature dew point at 3, temperature wet bulb at 3, W2 is equal to W3. Yun yung condition. Specific volume 3, H3. Hanapin natin itong mga parameters na to. Okay. RH3. $63.336. Tama? 366. 63.366. 366%. Dew point. Dew point is 10.002 degrees Celsius. Wet bulb, 12.944. Specific volume, 0.832. Yung H3 is 36.495 kilojoule per kilogram. Ayan, nakuha natin yung mga values. Okay. So, we can now find yung values nito. Okay, copying ko lang. Ilalaso ko muna. Ayan. Kilogram. Ayan. So, yung Q nung RH mo or the reheating is equal to M air H3 minus H2. Yung H3, yung M ng air is nakuha natin is 12 kilogram per second. Yung H3, 36.495 minus H2, going back, 29.357. 29.357 kilojoule per kilogram. Ayan. Cancel tong kilogram, kilogram. Ang natira is kilojoule per second. Kilowatts na yan. So, 12 times 36.495 minus 29.357. Yun. The answer will be 85.656. Yan yung reheating niya. 85.656 kilowatts. How about yung Q nung entire sa heating? QS sa heating. Sensible heat at heating. Heating process. Ito rin yun. Ha? Sensible heat. MR, CP ni air, multiply to dry bulb nung hot minus dry bulb nung cold. So, 12 kilogram in every second multiplied to 1.0062 kilojoule per kilogram degree Kelvin. dB, 17 minus 10 degree Kelvin. Cancel all the same units. Ang lumabas is kilojoule per second. So, that will be 12 times 1.0062 times 7, 84. So, that is 84.5208 kilowatts. That is the QS sa sensible heating. Okay, hanap na natin. Anong hinahanap? Yung final volumes ni air. Sa letter, haba nito, no? Letter C, hanap natin. Letter D, the final volumes of air. Tapos ito, nakuha na natin. What is the capacity of the cooling system in kilowatts and tons? So, letter D na lang. Letter D. Volume ni air at 1 is M ni air times specific volume at 1. That is 12 kilograms in every second times 60 seconds in every minute times V1. Ano ba yung V1 dyan? 0.907. 0.907 meter cube per kilogram. 12 times 60 times 0.907. The answer is 653. 653.04 meter cube in every minute. Volume of air at 0.2. Bale, that is M ni air, 2. This is 1 times specific volume at 2. That is 12 kilogram in every second times 60 seconds in every minute times ito 0.812 meter cube per kilogram. We cancel all the same units. Ang lumabas is cubic meter per minute pa rin. So, baguhin ko na lang yung dulo, 0.812. The answer is 584. 584.64 meter cube in every minute. And the final volume after reheating, mass ni air multiplied to specific volume 3. So that is 12 kilogram in every second times 60 seconds in every 1 minute times yung V3 nakuha natin. Ay, dito. 0.832 meter cube per kilogram. Cancel yung same units. That will be, mali. 0.832. Slightly higher dun sa second volume. 599.04 meter cube in every minute. So, very basic lang yung cooling and humidifying. Okay? Napaka-basic po. Kayang-kaya natin siyang i-solve. Okay? I think that will be all for cooling and humidifying. So, very basic yung ating system. Okay? Naintindihan ba yon? That will be all for today. So, quiz and exam next meeting. Have a nice day. Bye-bye.